Still talking about insulation, part two, and please try to read through the chapter. There's a lot of information about insulation. Homework 3 has been posted. It's due Friday. Has some information about insulation. If anything does not make sense, please email me or let me know tomorrow. So we talked about blown insulation, and we did one example about calculating volume and density and weight. And why do we need to know the weight of the insulation? Because you want to determine how much do you need to put in the cavity. Because when you buy insulation, they sell the insulation per pound. So I want to know how many pounds do I put. In case when I blow it in and it fluffs out, I want to pack it up and make sure it's the right density for the cavity. Otherwise, it's not going to work. Systems collapsing. So blown cellulose is ground up newspaper. They are treated with fire retardant. However, every time they get moisture, the fire retardant will dissolve quickly in the water and go away. So after a while, it's going to be very fire not retardant, and will drain all this fire retardant solution into lakes and the sea. So it's not really a good option, especially if you are living in a coastal area. So if you're in the Cape, you're in Boston, you're in the shore where it's very moist all the time, you don't want to use the station. They're very easy and fast. They have fast blow. You go there with an agitator and a vacuum-like machine, and you blow it in cavities, wait for it to settle, and to achieve the right amount of density in the cavity, you stop. And it's good to have it very covered and insulated, and probably you will see in some attics, they just have the blown insulation with nothing on top of it. That's not a good practice. You want to cover with either plywood or some plastic. Plastic would be ideal because that will prevent the moisture from going inside. The R value is between 1 and 2, so that's not bad, but that's not very good. It's 1 and 2 per inch, so you have to calculate how far you have to go high in the insulation. Some problems with it. It absorbs more water than wool or fiberglass. Again, have you ever seen a newspaper with water in it? It's highly absorbent. Which, what is the problem of absorbing water? Weight? Mold. 3, something you just said.
Run off of the fire retardant.
Yes, you run out of the fire retardant. And also, you are lowering your R value. So that's another problem with blown cellulose. However, it's very, very economical. So it's always an option to go if you have nothing. It's better than nothing. But for the attic, they recommend like an R value of at least 25. So if the DOE recommend 25, you're gonna need how many inches? At least 12 inches.
How do you know what you have in the house?
Say that again?
Like, how do you know what you have in the house?
What do you
It's
have?
Like, yeah.
You gotta go and measure. If it's blown insulation, you can go stick a stick and see how deep you have, how many inches do you have.
Okay.
And probably it's between 1 and 2. So probably you need at least 12 inches. Up to 130% of its weight at humid conditions. So it absorbs humidity very quick and it becomes very heavy. If you don't have very sturdy roof or ceiling, it might bulge a little bit. And it's going to be a really good environment for growing mold and bacteria, maybe mushrooms in there. Not good for coastal climate, again, because there's a lot of, usually houses vent a lot through the attic, so most of your vents go through the attic and you use that for ventilation in the summertime. It's always a good idea to open up the window in the attic and let the house breathe and create that chimney effect we talked about. So having this in an attic that's used for ventilation is not a good idea. Water can damage the fire retardant out, we said that. So these are some of the problems we have with Blown-in installation. So for adding insulation, we want density between 1.2 to 1.6 per cubic foot. We expect to have 15% of settling over at least 24 hours. So you're gonna blow it in, it's going to settle eventually over time, and you have to do another layer. Usually they come in 3 days and do another layer. For wall insulation, using cellulose, you want 3.5 to 4 pounds per cubic foot. That's density. To achieve whatever is written on the bag of insulation. They tell you this insulation will perform at this level if you have the right density.
No, this is just specifically to sell you.
Yeah, yeah. Questions? We're done?
No.
Yeah, write those numbers down, they're very important. And they are also available in your book. I'll provide a link to the DOE, Department of Energy, because they always update the requirements for the installation. And they tell you what is the new material, what are the hazardous material, what material are approved for installation. So vermiculite and perlites, they are, probably you'll hear about them if you're in construction, and they are heated rock pellets. When they are heated, they pop like a popcorn. Some of them are natural, some of them are man-made. You know those little peanuts for packaging?
What are they called?
Packaging peanuts. It's the same. They look the same. They're very foamy, but they're made out of rocks and some ceramics. And they're very, very useful if you are going to have poured cement or concrete as a wall. Again, they're very efficient, but also very expensive. They're popcorn-like. They have less voids than other fillings. So when you try to, did anybody see concrete being mixed? You know, generally speaking, they mix some kind of sand, the concrete material, the cement, and sometimes some rock, some pellets, depending on the civil engineer's or architectural engineer recommendation. So what is the difference between cement and concrete?
It's a powder version.
Huh?
I think the cement is a powder version.
Yeah. Cement is the material. Concrete is what you meant, the finished product. So concrete consists of cement. Sometimes they put reinforcement rods like steel, and rocks, sands, and sometimes they put also insulation material. There are some cement that are made to be in water, to solidify in water. So that is cement.
What do you mean by aggregate?
Aggregate is a mixture of rocks or pellets, or sometimes fine or hard sand, depending on the requirement. Huh?
Yeah, a picture of it?
So they have R value of 2.4 or less. So if you see some buildings, like some new buildings where they put ready-made walls, they've already been cast already in the factory, and they carry them with a crayon and put in place, probably they come already with the aggregate in it and some insulation value, and they're ready for drywall from the inside. So this is something you have to think about if you're going to also fill a cavity. The reason they also bring it up is it's an option if you're using cinder blocks or some kind of blocks or brick walls. You can pour this into cavities, solidify it, and put some aggregate to it, and put some vermiculite. Plastic foam panels, those are very common and they're very effective. They're made of polyurethane and polycitrine. The panels comes at a size of 4 by 8 feet, and they're easy to cut with a utility knife, and you can place them inside cavities or walls, or even inside door panels. They have either wood or aluminum sheathing. This one has aluminum. The price will vary depending on what kind of insulation do you have. Some aluminum is coated with Teflon, which makes it non-stick. Teflon is always a non-stick material if you have a lot of insulation. Now they are putting some silicone, but silicone is not as is more of a water retardant than insulation. So you'll see a coat here with Teflon on it, and this one looks like what they can make a walk-in cooler out of. They're also good for ductwork. However, you don't see a lot of ductwork made of this material in the Northeast, but you see it a lot in the South. Why is that?
More heat.
More heat. So these things, over time, they cook slowly with heat, and the temperature coming out of the furnace sometimes can be 180. So over time, you are slowly cooking this material, and it will be very crispy, and it will lose its insulation material. However, they have new material now that can be used as ductwork. They're also used for their rigidity based on the density. They're very dense, so they can hold shape, and it will make the doors or panels more sturdy. So, you can use that for that purpose. This is some of the ductwork. You can see made out of foam. If anybody works with sheet metal, it's very time consuming. If you order some sheet metal for a house, probably it's going to be done in a manufacturer somewhere and carried all the way to your house and assembled in there. It takes at least a week to install properly and also has weight. These things you can do with 2 people. You buy the panels, you have the schematics, and they also have a printing machine that will cut it for you. A lathe machine that will cut the shape for you. And if you look at this curvature here, they have a tool that will make it. You make the grooves, then you bend it, and you put some duct tape on it. They are very easy to make, and you'll see them more in businesses than in houses. Because again, businesses sometimes they have very fast turnaround, they want to install things fast, and they're easy to replace, and they're very visible. In houses, you want something that's going to last at least like 30 or 40 years. So these are relatively new. It's kind of like the PEX. They're very new. A lot of people don't have a lot of faith in them yet, but especially when it comes to heating. But for cooling, you see them a lot in Texas and the South. Because for cooling, they're perfect. Heating is still an issue. This is a picture of an example of a big warehouse where you see these things hanging out. And again, they're very lightweight, so you can use like small wires to hang them out. Again, the speed of the installation is a key element. And they do the job properly, especially if they are indoors. The pros and cons, they're very excellent tight space area, because again, you can get more cross-sectional area out of a square than out of a circle. So if you have a tight space, we don't have a lot of room for support, those are convenient.
Same for the type of material, right?
Yeah,
Oh.
polyethylene forms. R value between 6 and 7, which is very impressive. And you also, when you use usually galvanized steel, you'll have to insulate it somehow with some sheets and duct tape, so you have to deal with that issue. Can be used as filling for panels. If you have an empty panel of a door, you can fill it with polyethylene boards. They can be sandwiched in plastic, steel, or aluminum. If you have an aluminum door as a panel, you can stick a sheet in between. Think about it as a good building material and a good option. It will give you a lot of insulation. Usually you'll see something like that in doors like this one. This is empty, has nothing because it's go to the hallway. But if you look at outside doors, sometimes they're made out of metal, and inside they will insert a foam panel. The caveat of using those panels is R value,
You're mechanic.
cons,
Oh.
fallouts. It's the value deteriorated with time. And again, these panels we didn't have for the until the late 90s, so they're fairly new. So think about the R value being lower with time. Eventually you have to change the panels. Meanwhile, if you have the galvanized steel, the R value goes down of the insulation, the duct is still there, you take out the insulation and replace it. With these panels, you have to replace the entire panel. So that's another issue. Especially if you're looking, bless you, if you're looking for something that will have good insulation value. Susceptible to UV light, like most petrochemical equipment and material such as vinyl, plastics, polymers. Over time, they will lose value. They will start to become more brittle, and the bond between the polymers will start to break. So they are very susceptible to UV light, which means you cannot place them outdoors, or you cannot place them in somewhere where there's a lot of windows, and over time you will have the panel become more brittle and it might break. They get brittle. They are brittle in general. If you look at it, they're not that rigid. So if you drop something on it, it's going to break. If somebody stumbles on one of them, they will break, and they don't hold a lot of weight. So you cannot use that as a very structural item. For example, with GI, you do not need as much support, and sometimes if you can cut one part and connect it to the other with ease. Here we have very, very fragile and brittle system. Mechanical damage, what does that mean? It's easy to break. If you drop a wrench on it, probably it will dent. Over time, they will dent here and there, and that will lose their insulation value. They are very combustible. Again, that's based on the product that was out 7 years ago. Probably they have one that's less combustible. But again, that's one of the reasons that we don't use those with heating systems, mostly with cooling. And you don't want to place it near a place where you have a lot of flame or fire or hot air. Foam insulation, this is similar to the stuff you have in the can, but there's a lot of problems with it. They're easy to install, they're relatively inexpensive, they can add some structural strength as well, but the gases where they make the foam, it's a gas that reacts with air, so as soon as it gets some oxygen to expand and make the foam, the gases are very bad. That's why this guy is wearing a spacesuit. Probably at some point you got to use the spray foam, right? What is the problem you face when you use the spray foam?
Getting it out of your hands after.
Yeah, that's a big project, but that's not the most issue.
After it expands.
They expand. You have to cut them after you finish. Sometimes they do not go evenly. You'll have some cavities in the middle.
You've seen
So
walls
you-
buckle from it.
Yeah, you need some skills to get it in shape. What happened after like a year or so? Yeah,
Starts to dry
it gets
out.
crispier, start to become into crumbles, especially from the outside. If you look at the windows we have here, we used foam. It gets darker, and that means it's more and more brittle, and eventually it will fall out. However, these ones are supposed to be inside panels, and they're covered, so they do the job. They're easy to fix, but it's not recommended for long term. So it's not something you want to do for long term. What would you do instead of the foam?
Why do we even use that then?
Huh?
Why do we even use it then? If it's just-
I'll tell you why. It's convenient in some cases, but in here it's ideal to use the bats, good bats with the aluminum. Foams are really good if you have a house a wall that's already been built. You don't want to take the drywall out and put the bats, so you can inject your foam in there until it comes up from the other hole, and they do that a lot. They go through every cavity for here. In here, for example, you find the studs. You put a hole in here and a hole in here, and you keep pumping until it comes up from the bottom.
It
Fills
wouldn't
up.
push the sheet rock out?
Huh?
It wouldn't push the sheet rock out?
No, no. It's very soft in the beginning to protect the shape and stay in place. So that is one idea to do it. I don't know why. I think they did it this way just to show you.
No, they go over it with a big thing that grinds it all smooth,
Yeah.
so you can sheet rock over it.
It's interesting, but I don't see why this way to do it. Again, it's very, very economical. I think there's issues now with the blowing agent, the HCFC. I think here, there's still issue with the HCFC. Now they're trying to use CO2. It's polyethylene. It's the same material that you can use for the panels, but it has less density. It has great adhesion, it sticks very well, hence getting it out of your hand. And that's due to the viscosity it has, and also the polymer. It has good structural strength, especially in irregular shapes. So that square would have been nice to put up bats in it, but what if it's an irregular shape? What if it's something that goes up and down, triangular? It's a little bit challenging, so it's a good place to put blown insulation. It has very good air sealing capacity. Air will not go through it because it is polymer based. Good thermal resistance. R value from 6 to 7 per inch, so that is very, very convenient. Foam can have an R value to 3.6 per inch. That's for the foam. So that's the average. If you use 2 inches, probably going to be 6 to 7. So per inch is going to be 3.6. And again, depending on the material and the mix inside, so you always try to read the can or read whatever. The coming cans, like small can, and have bigger gallons you can pump out with air, and they give you a CO2 tank with it.
What was the R value of the foam can?
Huh?
3.6.
3.6 per inch.
Yeah. Got it? Yeah.
Oh, yeah, hold on.
We're good? Facing and barriers. So this is an example of something called a craft paper. And we use facing and barriers usually for moisture and gas infiltration. Moisture always travels from inside out and come from outside in. So these things are very important to include within your installation to prevent the moisture from coming in inside and out and outside in, and also some gases. They're called weather-resistant barrier. They look like baking sheets of wax paper, however they're thicker. And also they prevent air from coming inside and out, and they're very good for filtration. So if you look at the insulating foam or sheetrock, probably if it doesn't have the aluminum sheathing on it, it will pass air through it.
So is that basically the Tyvek stuff you see?
Oh, yeah, the house wrap.
Yeah, they use so first you're gonna put your bats, and you might just staple this this sheet on your walls. They're also called fire barriers because they do withstand some temperature. Facing, use those on the outside of the house. If you are going to put some kind of shingles, not shingles, what are they called? Facings, siding. You put craft paper because it will prevent the moisture from traveling. Aluminum foil, white vinyl sheathing, another type of facing. I've noticed also, like in a lot of houses, they use the plastic sheathing here, but if you look at the plastic sheathing, it does nothing because it does block the light, but if you look between the sheet, there is a lot of opening, so it's important to have some craft paper beyond that to prevent the air and moisture from coming in, otherwise it's going to be in it. This is where you put sheathing paper and insulation between concrete or between walls.
Can you go back to 15 real quick, please? Craft barrier, aluminum foil, white vinyl sheathing.
We got that.
All right, yeah, thank you.
Locations of where you put your sheathing, if you notice here, you want to staple that between the two boards because we said before that the corners, the connection between two boards usually is a good area for losing heat. When we do the heat loss calculation, and if you want to heat the basement, probably you will see in the booklet they go, when it comes to concrete, they don't go by the surface area, they go by the perimeter, which is the connection between the wall and the concrete. So probably that corner over there is leaking a lot of heat, and that's the reason sometimes we have those little, what are they called, sidings, What's the name?
So, something board, face board, yeah.
Baseboards. They kind of help a little bit with preventing water, moisture, or air to go around. I think it also works nice, but that's the main reason. The connection usually is not that solid between the wall and the floor. So, this is the sheet that you want for your, on the outside. Imagine this is the outside here.
That's what he was talking about, the tie back.
Yeah. So you put that in the, between the woods, otherwise the moisture gonna come in, and this is how moisture will travel through the drywall, also through the insulation onto the wood, and it's going to be very saturated with for a long time, and that's where you might have some rot. And if you look at a lot of those plywood panels, I don't think it's even considered plywood, what is it called? Particulate wood?
Shit board, OSB.
Yeah, because plywood has actually complete sheets. This is kind of more particulates. And they now the mix they put with wood chips is water retardant. So you might be able to pour water on it and it will not soak, but those are more expensive. The typical ones are very cheap, remade, and you need to put some barriers on
I've
it.
seen people use floorboards for the walls.
Yeah, that's not.
Tongue and groove, that's what it's about.
So this is what we were talking about. Who asked me why do we even use the foam? This is a good way to use the foam. You put holes and you fill in the holes for each cavity until it comes up from the bottom. Make sure it's that's for retrofitting. If some addition of the house was not heated, but now it's heated, you can go back and insulate either with board insulation or with foam. What? It's floor. Fix that later. So this is floor insulation. Why do we do this?
To prevent heat. from-
Yeah, so if you find out that you're losing a lot of heat from the floor, or getting a lot of heat from the floor, which will happen if you are doing cooling, right?
Mhm.
The cold air will go to the bottom, and if your basement is not heated, it's not cooled, probably gonna lose a lot of heat from the bottom. Especially if you don't have carpet, you're gonna lose a lot of the cold air, getting a lot of heat from the floor. So you wanna go, huh?
New homes, the only floor they usually insulate is the basement floor to the first floor.
Yeah.
The second floor is insulated.
Yeah, go ahead.
Did you say something about gases coming up?
Oh, what?
Gases last time?
Yeah, we'll talk about that, that's for the basement.
Oh.
For the basement, you want to insulate the basement with very thick barrier that no gas will go from the ground to your basement. Especially, it's become very common in New England because they have the radon gas, which causes cancer, and it's a natural gas.
Alright.
So, in some areas, either you have to test for radon or insulate your basement. Now, they insulate all basements for construction. So the floor, let's say this is the floor to the first floor, the floor to the first floor, and you start cooling, putting AC, and you realize that the floor is always hot and you're losing a lot of heat to the basement, and you do not intend to cool the basement. So you can go in and stick some bats and hang them with twine or some kind of boards. It's very important because again, you don't want the heat to escape to a place where you're not staying in, and you don't intend to heat or cool. So this is the DOE recommendation in 2015. These are the R values. They want you to have the zones are pertaining to the area of the country. And these are the recommendations here. So for attic, you want R30, usually, and 38 for colder area. Walls between R13 to R15. Floors R13. Slab should have this total R value between 4 and 8. Basement walls to the underground is going to be around like R11. And so this basement wall, framing cavity insulation, and the wall to the ground. Let me see if I can go through this. This thing is pretty awesome.
Gives you all that information.
See if it's updated. Yeah, please keep that link, it's really, really good link with a lot of information. So they always have new updates and new materials and new tips and tricks. If it's going to be your job, it's really good to be updated and know. See how they cover this with plastic? One insulation.
It's not really plastic, it's like a
Like tarp.
fiber,
Yeah, tarp
fibrous
material.
material, yeah.
Yeah. This is also from the DOE, where to insulate most common areas where you will leak temperature, basement floor, basement walls, any unheated space, you want to insulate more than a heated space. So as you said, you always want to insulate the first floor, probably it's a heated basement, and you keep the heat going out. Connection between the walls is also an area where you lose a lot of heat. Let me go to the DOT.
Does that have all the codes, the DOT website?
Yeah. These are the most common materials, and they also have procedures. And you can trust any information you find from this website because it's the DOE Energy. It's all most of the approved insulating materials. We've been through most of them here.
Put that in Blackboard?
Yeah, it's in the PowerPoint.
Okay.
So it's good to save that. And they talk about each one, what is the, how to use it, what density do you need. So all the information you can find here. And you also find some new material, like this one is very new. You know, like foam. Let's look at this one. Come on. Okay, it's not opening, but the link is in Blackboard. This is a good calculator that I found. Estimating appliances at home, electronic energy use. So it's a live calculator. You can pick the calculator you have and see how much it consumes and put the energy rate. And probably now you can do that by yourself because you did it in the home, or you did it in the quiz. But this calculator can be helpful, and it's good to have some resources. All right, thank you. And tomorrow we'll start the chapter